Okay, so I'm going to use the same system that we just used in the previous one where we showed that they intersected at the point 1, 1. Okay, so we're going to show that with substitution as well as, I think your instructor called it linear addition, which that's often called it. I have always called it elimination, and you eliminate by addition or eliminate by subtraction. And I'll show you why I call it elimination, why I emphasize that as soon as we get there. So first let's start with substitution. So we're going to substitute. You can substitute for an x or a y. It does not matter. So the reason why you're doing that is because you're going to substitute one of the equations for the x or the y, whichever is easiest. And then you're going to plug that in for the x or the y of the other equation. So here, I wouldn't want to have to get x or y alone on this one. Although, since we've already done this problem, we've already gotten y alone, so you could do that. But assuming that we had never seen this problem before. So I wouldn't want to do one of those. I would either get x or y alone on this one so that I can plug it in for the other one because there's nothing attached to those. When there's nothing attached, say that there was a 5 next to this y, then I would go for x. I would get x alone. If there was something attached to the x, then I would get y alone because whatever's alone already, and you just have to move something over, that's going to be easiest. So let's go ahead and get y alone. So I'm going to minus x over. I get y equals negative x plus 2. Okay, so now that I just got y alone, that means that for both of these equations, y is going to end up equaling negative x plus 2. So I'm going to plug this in for the other y. So you're substituting one equation in for the other equation. So since we got in this one, y equals negative x plus 2, then I'm going to use negative x plus 2 and plug it in for the y. So it's substituting. So when you substitute something, so for example, if I had a substitute for my class, I wouldn't go to school and be there too. If I'm substituting, my substitute is taking my place and I'm going away. Same thing with the y. Negative x plus 2 is going to take y's place and y is going to go away. Okay? So we're going to have negative 6x plus 2, and now I'm taking away y. And I'm going to substitute negative x plus 2 in for there. Equals negative 4. Okay, so I'm going to distribute 2. And then 2 times negative x is negative 2x. 2 times 2 is positive 4. And then I'm going to add these, so negative 6 and negative 2 makes negative 8x. And then I'm going to minus 4. So negative 8x equals negative 8. And then I would divide both sides by negative 8. I hope you can see this okay. And negative 8 divided by negative 8 is 1. So we got that the x is 1, which we did before, right? We got the x was 1. And then once we plug 1 back in, we get to choose which equation. We can plug it in for this one or that one. I always told my students, make sure that you plug it into one of the two original, just because you're less likely to make a mistake. But technically, you could plug it in for this one too. It doesn't matter. I would plug it in for one of the originals though. So let's do it in for this one. That one looks easier to me. So instead of x, I'm going to write 1. So 1 plus y equals 2. Now you could think 1 plus what would give me 2? 1 plus 1 is going to give me 2. Or you can just solve it. So minus 1, and 2 minus 1 is 1. So I just got that the x was 1 and the y was 1. So if I wrote that in point form, so x comma y, that would be 1, 1, which is the same thing we got there. Okay, let's try using the same system and make sure we get 1, 1 again. But this time, let's try elimination. Okay, so as a reminder, our answer should end up being 1, 1. And my equations are negative 6x plus 2y equals -4, and x plus y equals 2. Okay, before I do this one, no, let's go ahead and do it. And then I might make one more video of some more examples of elimination, because elimination, I think, technically, is the trickiest to really comprehend, but in the end, it's the easiest one, and you usually get the answers correct all the time using elimination. That's the one that I prefer. Okay, so we have to, it's called elimination, I call it elimination, because you either are eliminating the x's or you are eliminating the y's. So your goal is to either get rid of the x's or the y's, and you get to choose what you want to get rid of. So I can get rid of the x's, this x, and we're eliminating through addition, like you said. So we're trying to see -6 plus what is going to give me 0, so that they are eliminated. -6 plus what will give me 0. -6 plus 6 would give me 0, so then I would want a 6 in front of the x. So I can multiply everything by 6. If I wanted to eliminate the y's, here is a 2y. So then 2 plus what is going to give me 0, so that they're eliminated. So 2 plus -2. So it's just the opposite. So if I had a 7 in front, I would want to multiply by -7. If it were a 5 in front, I'd want to multiply it by -5. If I had a -8 in front, I'd want to multiply that by 8. Okay, so you're just trying to make them opposite of one another. So let's go ahead and multiply, depending on if you want the x's or the y's. So I'm going to multiply for the x's. I usually like always multiplying by the x's, just because I like to keep in the same thing every time, but it's up to you. So if this is -6, we want +6 here, so I have to multiply all 3 terms by +6. So I'm going to have 6x plus 6y equals 12. And then I'm going to rewrite this underneath, so just so that it makes it a little easier. Okay, now I'm going to add, so it's going to be addition. So 6x plus -6, those eliminated, that's 0, it's gone. Okay, 6y plus 2y, that's going to give me 8y. 12 minus 4 is 8, so if I divide both sides by 8, y equals 1. But yep, y equals 1. Okay, let's make sure when we plug y back in, we get x is equal to 1 too. So let's do x plus y, which we got was 1, equals 2. So I minus 1. So x equals 1. So it's 1, 1. Or sorry, x and then y. So 1, 1. That's our answer. Okay, I'm going to make up some more problems and do one more video of just a few more examples of that.